All right, today we are going to do lesson 11.6, and we're going to add and subtract rational expressions. Now remember, last week we learned how to simplify rational expressions. We learned how to multiply. We could simplify before we multiplied. That's all going to change a little bit today, because remember, with fractions, I want you to think back to elementary school. When you wanted to add and subtract fractions, what did you have to have? A common denominator, all right? So we're not going to be able to simplify a numerator and a denominator that are across from each other today, because we're adding and subtracting. Now, fractions can be simplified when we're looking at numerators and denominators that are on top of each other, okay? But not ones that are across from each other like we did last week, all right? And we're not going to simplify any of our fractions until we get down to our final answer. So let's look at this first example. It says simplify the expression. So remember, our focus needs to be on the denominators. So if you look at letter A and you look at both denominators, do we have a common denominator? We do. Yes. So when we have a common denominator, we get to go straight into our answer. So one fraction bar, and the common denominator will not change. When we have a common denominator, it stays the same for our answer. So we just bring down y plus 5. Now we look at our numerators, and remember, when we're adding and subtracting, we're looking for like terms. So 3y plus 4. Are there any like terms that can be combined? No, so we're just going to bring down 3y plus 4. Now, once we have it down to the final answer, we look to see if the problem can be factored any further. So this technically would not be our final answer until we're sure that nothing can be factored. So look at your numerator, look at your denominator. Can either of those be factored down further? Now remember, that means, can we pull a GCF out? Can we do the X method? Is it a special product? Is there anything in the numerator or denominator that can be factored down further? No. So in this case, everything's factored. Can anything simplify or cancel in this problem? Why? No. Remember, binomials cannot be looked at as separate parts. That is 3y plus 4. That's one thing. And then y plus 5 is one thing. So can anything be simplified or canceled in this problem? No. The answer is no. So this is actually our final answer. All right, now let's look at letter B. Look at the denominators. Do we have a common denominator already? Yes. So we're going to bring down the x plus 2 because our denominator won't change once it's common. But we got to be really careful when we're dealing with a subtraction problem, because remember what happens when we have a subtraction problem? Okay? Then the minus has to be applied to everything behind it. So let's bring down the first numerator. It won't change, it's just a 4. But what happens when I apply that negative sign to both the x and the 4? Kennedy, what am I actually bringing down for that second numerator?
Or no. Yes. No.
Hold on, you're applying it to both things behind it. You got to apply, it's like the distributive property. So instead of that being a positive x, it's actually a what?
Negative x.
So we bring down a negative x, and instead of a positive 4, it's negative 4. Good. So we're going to apply the minus sign to everything behind it. Now we can look for like terms. Fernando, do you see any like terms in the numerator that we could combine?
4.
4 and
4.
What kind of 4 is that second one though? Negative 4. Good. So what is 4 minus 4?
0.
0. And since we have a negative x in the numerator still, we don't need to bring down the 0. We're just going to bring down the negative x and of course the x plus 2. Now, we've got one fraction. Can it be simplified any further? Can we factor down any further? Can we cancel anything out? Or is that our final answer? That's your final answer. You got a monomial on the top, a binomial on the bottom, so nothing else can be done. All right, so be very careful when it's a subtraction problem. When you're bringing the numerators down, you got to apply the minus sign to everything behind it. Zach?
If it's a binomial, you can't do anything to it?
Not unless there's a GCF to pull out, or if it's the difference of squares, and that is neither. Okay? All right, now look at letter C. Check the denominators. Are they alike already?
Yes.
Yes, so we're going to Bring down the denominator just as it is. We're going to bring it down as 2x squared minus 7x plus 5. Okay? Bring down that first numerator. Now, why am I not just combining my like terms right now? Because it's what kind of a problem? It's a subtraction problem. So I'm going to bring down, Noah, what for the second numerator? Negative 3 plus 3x. Good. We got to apply that minus sign to everything behind it. So that's a negative 3 we bring down and a positive 3x. Now, Noah, do you see common denominators that we can combine? All right. Anybody disagree with that?
Me.
Hey, Jevinson, what are some common denominators that we can combine? I'm sorry, I'm saying common denominators. Any like terms that we can combine? Okay, we got a negative 3 and we got a 1. So what is 1 minus 3? Negative 2. Any others?
3x and negative x.
We got a negative x and a positive 3x. So we combine those and get what?
Negative 2x.
Is it negative?
Oh, positive.
Positive 2x. Good. Over, of course, we're bringing down that common denominator. 2x squared minus 7x plus 5. Now, here is my suggestion. Anytime you have a binomial and the variable is listed second, I would rewrite it so that the variable is actually listed first. So I would come down here and I would do 2x minus 2. All right, and I'll show you why here in just a second. But I would always try to get that variable first in the binomial. Now we're supposed to look, can we simplify the numerator or the denominator any further? Can we factor it any further? All right, Zach, which one can we factor?
The denominator.
For sure the denominator. All right, and what method are we going to use?
The x. The x.
We're going to use our x method, but we're also going to have to do what kind of factoring? AC factoring, because we have a leading coefficient. So when we AC factor, what do we do first, Zach?
You gotta multiply the first and the last.
Good. I'm going to multiply my A and my C, and what am I going to get? We're going to get 10. So what goes at the top of our X?
The negative 7.
Negative 7, and at the bottom? The 10. All right, good. Reagan, will my signs be the same or will they be different?
Different.
All right. They're going to be the same, and they're both going to be what?
Positive. Or negative.
They're both going to be negative. Awesome. Okay, the second sign was positive, the first sign was negative, so they'll both be negative. So factors of 10, we got 1 and 10, 5 and 2. So Reagan, which one of those sets is going to work for our problem?
2 and 5.
Good, we're trying to get 7, so 2 and 5. So Reagan, when we factor these, what do we have so far?
X minus 2 and then x minus 5.
Good, but are we finished?
No.
No, this is AC factoring. So if we slide and multiply, we then have to slide and divide. And what are we dividing by, Zach Sizemore? 2. Very good. The leading coefficient. If we go back to the problem that we're factoring, the leading coefficient is a 2. So that is what we are going to divide by. All right, so Zach, when you do your sliding and your dividing, what do we get as our factored answer?
X minus 1.
Okay,
2x minus 1.
very good. Now look at that. 2 divided by 2 gave me 1, so we got x minus 1. And then, of course, 5 over 2 won't divide evenly, so we bottoms up. So that's 2x minus 5. Now you notice I brought my final answer over here into my what might be my final answer. All right, what about the numerator? Is there anything I can do to factor the numerator down further? Ellie?
Divide by 2.
There is a GCF of 2. So when I pull out a 2, Ellie, what does that leave me with?
X minus 1.
Okay. Because 2x divided by 2 is x, and negative 2 divided by 2 is negative 1. Very good. So, looking at this problem now, everything is factored as far as it can be. Does anything cancel or simplify? Janicia, anything you see that will simplify or cancel?
The x minus 4.
The x minus, good. I have a binomial of x minus 1 in the numerator and one of x minus 1 in the denominator. So they cancel and they equal what, class? 1. Anything over itself equals a 1. So my final answer, and you can write this below it, but your final answer is what? 2 over 2x minus 5. Awesome. Now, let me take you back for just a second to this right here. Had you left that as negative 2 plus 2x, could you have still pulled a GCF out? Yes. All right. You would have pulled out what kind of a GCF? Negative 2, which would have left you with 1 minus x. Okay, now think about this for just a second. What if this had said 1 minus x? Would you still have been able to cancel these two binomials out? Okay, we could cancel them out, but instead of equaling a positive 1, they would have equaled a negative 1. Remember, because they would have been the opposites of each other. This would have been 1 minus x, and this would have been x minus 1. The signs would have still matched, but the terms would have been swapped. So it would have canceled, but it would have canceled out to be a negative 1. And of course, we leave the negatives out in front of the fraction. All right, but that is why I always think it's a good idea right here, if you can put the variable term first in the binomial, do that, because it helps make it a little bit simpler when you get further down in the problem. All right, Zach? It would not be wrong. All right, it would not be wrong because you can cancel. You would just have a negative sign out in front of the fraction. Okay? All right, anybody else? Awesome. Now, this is where it gets more complicated, because now we've got to look at what do we do when the denominators are not the same. What do we do when the denominators are not the same? So first of all, we're going to factor the given denominators first. That's all we can do. We got to factor those denominators down as far as they will go, and then we're going to look for pairs. Any pairs that we have will get used one time, and all of our leftovers get used. So you say, what are you talking about? All right, look at the example I gave you. Can we factor either denominator down any further? Yes or no? This should be a quick yes or no. Can we factor either of those denominators down any further? No. They're binomials. They're not difference of squares. There's no GCF to pull out. We can't factor either of those down any further. So now we have to start figuring out, okay, these are the denominators. What's our common denominator? And if you think back to elementary math, when you were finding common denominators, remember, you are multiplying. This times this gives me the common denominator. So here's the quick way to do it. What pair do you see? What pair of binomials do you see? So each of my denominators, because what I'm doing is I'm rewriting each fraction with the common denominator. So x plus 2 is part of my common denominator, just once, because a pair gets used once. And then what's left over? What's another binomial that you see that doesn't have a pair, that's all by itself? X minus 1. So the common denominator is going to be x plus 2 times x minus 1. You say, but you're writing it down twice. Right, because right now I'm just rewriting each fraction with the common denominator. So the common denominator is this x plus 2 times x minus 1. All right? Now, let's look at example number 2, letter A, because this one's a little bit different. Neither denominator factors down. So this is almost, I don't want to say too easy, but don't complicate this. All right? Start by looking at your numbers, 3 and 6. Which of those would be the common denominator? If all you had in the denominator was a 3 and a 6, which one would be your common denominator? The 6, all right? Remember, for denominators, you're looking for the common multiples, not the common factor, the common multiples. So obviously we would get 6. So I want you to rewrite each fraction and go ahead and give it that 6, okay? Because your common denominator is going to be 6. Now, we have an x squared and an x. So obviously we're going to have x, but x to what power? Remember, when you're trying to find your LCD, your least common denominator, which is also your LCM, your least common multiple, are we going to take the highest exponent or the lowest exponent? Think about your GCF. When we pull out GCFs, do we take the highest exponent or the lowest? We take the lowest. So it's like the opposite. We're trying to find the least common denominator, but we're going to take the highest exponent. So which exponent is higher? The 2. So x squared is going to be part of our common denominator. Now, this is where you, again, go back to elementary. I got to figure out what I did to the original denominator to get to the new denominator. What did I multiply by? So how did I get from 3x squared to 6x squared? I multiplied by 2. So what am I multiplying my numerator by? The same thing. I'm multiplying it by 2. So what is 5 times 2? Awesome. How did I get from 6x to 6x squared? What did I multiply by? A 1 what? A 1x, right? 1x. So what am I going to multiply the numerator by? 1x. So 7 times x is 7x. Now I can add my fractions together. My common denominator does not change. Can I do anything to 10 plus 7x? No, they're not like terms. So I am going to put that the variable first in my binomial. So 7x plus 10 over 6x squared. Now, can either of those be factored down further? No. So will anything cancel or simplify? No? All right, so this is my final answer. Again, 7x plus 10 is a binomial, so I have to look at it as one whole piece. All right, letter B. Letter B. Can I factor either denominator down further? Yes or no? No? So what is, Janicia, what is my common denominator going to be this time? Do I have any pairs? Are you sure? Remember, one of those is a monomial, one is a binomial. I cannot separate a binomial in my mind. That is an x plus 1 and that is an x. So do I have any pairs? No. So what is my common denominator going to be? And I got to use everything I see. So I've got an x and what? No. Give me the whole binomial. Remember, the whole I cannot look, that's not an x and a 1. That is x plus 1. So I've already used this denominator. So what's the other denominator? So x plus 1 is the other part of my common denominator. Okay? Does everyone see why those are two separate things? That's a monomial and that's a binomial. So you cannot say, oh, well, there's a pair of x's. No, there's not. There is an x and there is an x plus 1. All right? Now, let's figure out our new numerators. How did we get from x plus 1 to x times x plus 1? What did we multiply x plus 1 by to get x times x plus 1? X. So what are we going to multiply our numerator by? X. Awesome. We'll come back in a second. All right? This denominator, how did it change? What did it get multiplied by? X plus 1. Very good. Now, here's another way I'll word this. You'll hear me word it this way. Look at the original denominator. What's missing from the original denominator that's in the common denominator? The x is missing, right? So that's what we multiply our numerator by. What's missing from this denominator that's in the common denominator? X plus 1. So we multiply our numerator by x plus 1. So that's another way you can word that. Now, what happens when you do 2x squared times x? Everybody should be able to tell me this. What do we get? 2x cubed. Awesome. But what happens when we have to do x minus 1 times x plus 1? What method are we going to have to use in order to multiply x minus 1 times x plus 1? What is it? Okay. If you see the shortcut, it is absolutely the difference of squares. Everything matches except the signs, so we can quickly multiply the x's and get what? What's x times x? And negative 1 times 1 is negative 1, okay? Or you can FOIL. If you need to, you can take x minus 1 times x plus 1 over to the side and you can FOIL it, but you're going to get x squared minus 1. All right? Now, let's begin to write our final answer. We've got x times x plus 1 Do we do anything to the numerator in the first fraction? Or can we just bring it down? Bring it down. But what has to happen to the second numerator? What are we actually going to be bringing down? Okay, this is a subtraction problem. So we're going to bring down negative x squared and positive 1. Awesome. Now look at both parts. Can either of these be factored down further? Yes or no? You're hesitating, which makes me think you think maybe yes. But look at the degree of the numerator. What's the highest exponent in the numerator? Have you learned how to factor down when the leading degree is a 3? Is there a GCF you can pull out? No. So guess what? This is your final answer. Okay? Zach.
Why is it negative x squared plus 1?
Because when it's a subtraction problem, remember this whole time we've been talking, every time you have a subtraction problem, you have to apply that negative sign to everything behind it. All right? All right, let's look at letter C. Look at your fractions. Look at your denominators. Can either of those be broken down further? Listen, here's what you're not remembering. Sometimes factoring is simply pulling out a GCF. So you should be looking for GCFs every time you're looking. So can either of these be factored down further? Yes. Which one? The 2x minus 6. All right. So let's bring it down. What comes out? What's the GCF for 2x minus 6? 2. All right. And that leaves us with, what's 2x divided by 2? And negative 6 divided by 2. Negative 3. And of course, we're going to go ahead. Let's bring the rest of the problem down. Anytime you do have to factor one of the denominators down, I just bring the whole problem down. Okay? Now we can find our common denominator. Ajane, do you see what our common denominator is going to be this time? You see a matching pair? All right, so we know we're going to use x minus 3 once because a pair gets used once. Any leftovers that we're also going to have to use? The 2. So our common denominator is 2 times x minus 3. Now, look at your original denominator and your common denominator. Is there any difference between the two? No. So when the denominator doesn't change, neither does the numerator. So just bring your 9 down. All right. What changed from this original denominator to the common denominator? 2. So we have to multiply our numerator by 2. And what is 3 times 2? 6. Now we add our numerators. What's 9 plus 6? 15. Bring down the common denominator of 2 times x minus 3. Does anything cancel? No. So this is our final answer. Okay? Questions on this one? You like this one? No? Okay. Awesome. Well, you're really going to hate this one then. All right, letter D. Now look at your denominators. Can either of them be factored any further? No. So that's nice because now finding the common denominator should be super simple. What is our common denominator going to be? 7x. I heard somebody start it. 7x minus 4. And what else? 4x plus 3. So since neither can be broken down any further, I just have to use both of them in my answer. Okay, or both of them in my common denominator. So they don't factor down further, which is nice, but I do have to use them both. All right, so let's look at the first, the original denominator and the common denominator. What is missing from the original denominator? So I'm going to multiply my numerator by, okay, everybody understand that? I've only got here one person telling me, but does everybody understand why I'm multiplying by that? Give me some nods. Okay, awesome. Look at the second one. The original denominator has the 4x plus 3, so what's it missing from the common denominator? So I got to multiply that numerator by 7x minus 4. All right, now let's take this first part. Let's take it over to the side because what am I going to have to do to multiply 3x plus 10 times 4x plus 3? What method am I going to have to use to multiply those? FOIL. So let's review FOIL. F stands for the first term. So what are my first terms? 3x and 4x. When I multiply those, I get 12x squared. All right. My outside terms are what? My outside terms, I have 3x and I have 3, which gives me 9x. My inside terms, I have 10 and 4x, which gives me 40x. And of course, my last terms are 10 and 3, which gives me 30. Awesome. Now, when I combine like terms, what does that give me in my numerator? 12x squared plus 49x plus 30. Now, is it necessary for me to move the x times 7x minus 4 over to the side? That's a monomial times a binomial. So I'm going to use what property? I heard it. Say it louder. The distributive. So x times 7x, 7x squared, and x times negative 4, negative 4x. All right. Now, I'm going to begin to pull my answer down. Denominator's not going to change. I'm going to pull down my first numerator just like it is. 12x squared plus 49x plus 30. But what happens to my second numerator? This is what kind of a problem? Class?
Subtraction.
Subtraction. So Izzy, what's coming down for that second set of numerators? That's negative 7x squared plus 4x. Awesome. So now we combine our like terms. All right, we have 12x squared and what's its like term? Negative 7x squared, which gives me 5x squared. I've got 49x and 4x, which gives me 53x. And of course, plus 30 just comes down. Now, can either of these factor further? I told you were going to hate this one. Yes, okay. So I have to use my AC method. So 5 times 30 is 150. At the top is a 53, and at the bottom is 150. Are my signs going to be the same or different?
Same.
They're going to be the same. And my factors of 150 are 1 times 150, 2 times 75, 3 times 50. Do you see any that will work? 3 times 50. All right, we're going to finish this one, so stay with me. So we got a 3 and we got a 50. So that's x plus 3 times x plus 50. But we're not done. We have to slide and divide. What are we dividing by?
5.
5. So, Fernando, what do we get
5.
when we finally have this factored?
5x plus 3.
5x plus 3 because we have to bottoms up and x plus 10. Now, that all goes over 7x minus 4. So here's our last question. Does anything cancel or simplify? No. So, guess what? Go right up here and box in your final answer. All right? I have no problem with you going back. When you realize that nothing cancels down here, go right back up to the problem before it, and you don't have to rewrite this, okay? Just go right back up to what you already had, box it in as your final answer. But this will be your final answer. All right, and that is 11.6.